Hi, this is a continuation of our earlier lecture on areas of parallelograms and triangles. This time we'll look at another theorem and then apply what we have learned in a question. So theorem number 3 states two triangles having the same base and equal areas lie between the same parallels. Now the proof of this theorem is very elementary. Uh, the way to do that would be to consider two triangles, let's say A, B, C, and another triangle which shares the base BC and it lies between the same parallels, and let's just call it point D, let's just say that. And so we have AD parallel to BC. We have to prove that this is what we have to prove if we are given that area of ABC is equal to area of DBC, right? This is what we have to prove. Now let's see how we can do that. One way to do that would be to consider the heights corresponding to side BC. I'll call this H1 and I'll call this H2, right? H1 and H2. So from our earlier lecture we have learned that area of ABC would be equal to half of base, which is BC, into height, the corresponding height, which is H1. Also area of BDC is equal to half of BC into H2, that is again base and corresponding height. Now we are given that these two areas are equal, so while equating them we get half of BC into H1 is equal to half of BC into H2. This implies H1 is equal to H2, and so we know that these two heights are equal, and so we know that AD is at a constant distance from the line BC, and so therefore AD parallel to BC. Hence proved that two triangles having the same base and equal areas lie between the same parallels. Let's look at a question in which we will apply some of the things that we have learned in this lecture. We are given this geometry in which ABCD is a parallelogram. ABCD is a parallelogram. We have CP parallel to AB. CP parallel to AQ. CP is parallel to AQ, and PBQR is a parallelogram. PBQR is a parallelogram, and we have to prove that area of ABCD is equal to the area of PBQR. So let's take a second to analyze this question. How can we prove this? So we can think about this area, which is, if I say join AC and join QP maybe. So let's try and join QP and see what we get from this. Now something interesting that we notice is that by joining AC and QP we have divided both the parallelograms into two congruent triangles. So ADC is congruent to ABC, and not strictly, but these two triangles are congruent and these two triangles are congruent. So if somehow I could prove that the area of this triangle is equal to area of this triangle, I could simply double that and claim that the area of this parallelogram is equal to area of this parallelogram. So now let's investigate if there is a way in which we can prove that the area of this triangle is equal to area of this triangle. And what comes to our rescue is the fact that AQ and CP are parallel. CP is parallel to AQ. And so let's consider triangle ACQ and APQ. Triangle ACQ and APQ. Notice that they share the common base AQ and also have the parallel. They lie between the same parallels, that is CP and AQ. So what we can write is area of AQC is equal to area of AQP. AQC is equal to AQP area. So now let's write the area of AQC in terms of this area, and this area. So we have area of AQC is equal to area of ABQ plus area of ABC, right? And now we can write AQP as this area plus this area. So we have area of AQP is equal to area of ABQ plus area of PBQ. Now we know that these two are equal, and so let's equate these two equations. So we get area of ABQ plus area of ABC is equal to area of ABQ plus area of PBQ. And so these two cancel, and we have area of ABC is equal to area of PBQ. Now multiply these equations, this equation by 2, so we get 2 of area of ABC is equal to 2 of area of PBQ, and so therefore we know that the area of ABC is half of the area of the parallelogram ABCD. So therefore 2 times the area of ABCD is equal to area of ABCD, and similarly 2 times the area of PBQ is equal to area of PBQR. Hence proved. So that's how you use what we have learned in this lecture to solve questions. So this is all we had to say. This is all that we had to say about areas of parallelograms and triangles. For now, this is all. Thank you.